So I'll be thinking about this region, but also, oh, let's switch that to say 3. I'll be thinking about this region, but really I'm thinking about volumes in this region. It's probably less dramatic on camera. I would totally do this if we were in class. So the idea here is that this arbitrary cross-section that I take, if I think about a slice perpendicular to the x-axis, I don't draw well in 3D, so instead, apparently I don't cut particularly well in real life, but can we pretend this is a circle? So if I think about this shape, what this is saying is that I'm going to have at each possible value of x, I'll be taking a slice, and that slice will have the shape of a circle. So for this value of x, that's how big my circle would turn out to be. But at a different value of x, where this height was bigger, I'd end up with a bigger circle. And we'd be stacking all of those circles up to form a volume. Now, technically, each of these circles has a cross-sectional area, but it also has a little bit of thickness. And that little bit of thickness is that dx. Because I know my cross-sections are circles, even just thinking about partial credit, once I know the shape of the cross-sections, I can write out what my volume equation should be. So I know that when my cross-sections are circles, the area of a circle is pi r squared, and then I'm going to have a little bit of thickness, or dx. The only thing I have to figure out is on our picture how that radius relates to the functions in our picture. Well, that cross-section, again, that's a slice, but that's a slice that corresponds to a circle. So that piece, if I kind of transferred it down here, it's a circle with a little bit of thickness. So that cross-sectional height that we're seeing isn't the radius, it's actually the diameter, or twice the radius. So that height is twice the radius. And based on the picture, I would get that height by looking at the y value, and our y value is x. Relating those two, I know that twice the radius would be equal to x, or my radius is x over 2. Now I can plug that into our cross-sectional volume. So I have pi, my r is x over 2, that whole thing would be squared, dx, and we'd be integrating these from 0 to 3. And if we only have to set it up, I would definitely quit there. If you had to actually evaluate this, I'd pull the pi out in front, and then I'd think about this as x squared over 2 squared, or we'd be dividing by 4, 0 to 3, x squared dx.